I'm Anil Kumar. Welcome to my series on linear systems. We have taken up few examples based on slopes and intercepts. Here is another real life situation. The question here is, speed of the car when brakes are applied is shown in the graph below. Explain the significance of x-intercept, y-intercept and the slope. Write a possible linear equation to model this situation. So the graph here provides you with car speed versus time. Speed, that is velocity, is given in meters per second along the vertical y-axis, and time in seconds is given to you along the horizontal x-axis. So when I say x-intercepts, I mean this point, right? And when I say y-intercept, I mean that point. And you need to find the slope of this and explain its significance. So I hope the question is absolutely clear. You can always pause the video, answer the question, and then look into my suggestions. So let's read the values of x and y-intercept from the graph. So we have x-intercept at 5 seconds. At times, we would prefer to write this as t-intercept, since along the x-axis we have taken time, the independent variable here. At this time, the velocity of the car is 0. So the interpretation here is that the car stops in 5 seconds. Right? So there is some brakes being applied here, it seems. So the velocity is decreasing at a constant rate. So car stops in 5 seconds. That is the interpretation for the x-intercept. Now, let's look into the y-intercept part. So y-intercept, which I could have said as velocity v-intercept, right? Let me write or. It is 20 meters per second. It really means that the velocity of car was 20 meters per second when brakes were applied. Right? So that is the interpretation which you can give with x and y intercepts. How about slope? Now let's talk about slope. So we are done with x-intercept, y-intercept, and now we are talking about slope. The slope is rate of change and it's a constant slope. So we could consider these 2 points here. We can find slope with the equation y2 minus y1 over x2 minus x1. In this case, we're talking about velocities, right? So we can say v2 minus v1 over t2 minus t1. Good points to take are 20, which basically is 0, 20, and this point 5, which basically is 5, 0, right? So using these points, we can find the slope. So let's figure this out. So we get slope as, so 0 minus 20, difference in y values, over 5 minus 0, which gives us minus 4. Now look into the units. Velocity is meters per second and time is also in seconds. So what we get here is minus 4 meters per second squared. Now that is very important to understand. So that is the acceleration which is negative, right? So what we get here as an interpretation is slope here is constant acceleration of negative 4 meters per second square, right? So we also call it deceleration, right? So it is decreasing, the velocity is decreasing at a constant rate. So we can say velocity is decreasing at a constant rate, or deceleration, okay? So that is how we could explain it. And now let's get back to the question of writing the equation for the given function. So you could use the slope-intercept form to write the equation. Since dependent variable is v, so we'll write velocity v is equal to rate of change is minus 4 time t, initial value plus 20. So that is the equation, right? So that is how we could provide the equation where the units are velocity in meters per second, time in seconds. Perfect. So that is how we are going to answer this question. I hope that helps. Feel free to write your comments and share your views. If you really like and subscribe to my videos, that'd be great. Thanks for watching and all the best.